So for today, we will tackle about the feed formulation. So what is feed formulation? It is the process of mixing together various feed ingredients, vitamin and mineral supplements, and additives at the right proportions to produce a diet that contains the required amount of nutrients and energy. So there are major factors governing the choice of feed ingredients. First is the sustainability of ingredients for species being cultured, which is type and the quality. Feed ingredients are chosen based on their nutrient and energy content, digestibility, and palatability. They must be free from adulteration and toxicity. Second is the quantity and regularity of supply. Select ingredients which are regularly available in sufficient quantities. And lastly, the cost. Select feedstock which are cheaper in terms of cost per unit weight of protein. So which of the following examples of ingredients is cheaper? Assorted fish meal containing 55% protein and costing 22 pesos per gram, or the anchovy meal containing 70% protein and costing 27% per gram. So for the calculations of cost per kilogram of protein, using the formula, divide the cost per kilogram ingredient to the percentage of protein, where the assorted fish meal has 40 pesos per kilogram protein, while the anchovy has 38.55 pesos per kilogram protein. Note that anchovy meal is cheaper in terms of per kilogram of protein, although higher in cost on the basis of per kilogram of ingredient. So for measure in balancing a feed ration, there's three methods: the person square technique, multiple or trial and error method, and the algebraic method. So person square is a technique of balancing feed ration which calculate the exact quantities of ingredients for the feed formulation based on the required protein level given. So for the example is the 4 diet with 2 ingredients, where formulate a diet to contain 25% protein using the fish meal with analyzed crude protein content of 53.4% and fine rice bran with 12.9% of adjusted crude protein. So to calculate this, first is place the grain and their respective crude protein content on the left-hand corners of the square. To calculate the difference between the middle value and the value, the bottom and top left-hand corner of the square, and place the result diagonally opposite, where top left minus middle equals the bottom right, and the bottom left minus middle is the top right. Calculate the percentage of each grain, add the two portions given to give the total, and calculate each feed as a percentage. Note that disregard the negative or positive value of the numbers. Then calculate the difference of the middle value in the rice bran divided by the total of the two difference equals to the percentage of the rice bran, same as goes with the percentage of the fish meal. So to make 100 grams of this feed, we must mix the 30 grams of the fish meal and the 70 grams of the rice bran. So for the second example, for diet with 3 or more ingredients given designated percentage, shares or parts in the formulation. Similarly, formulate a diet to contain 25% protein using the following ingredients. So for the group 1 is protein sources, where fish meal has 1.5 parts multiplied by 59.8% ACP is equal to 89.7%. And the soybean meal has 2.5 parts multiplied by 47.5 ACP is equal to 118.75%. where the total of two protein sources has 4 parts and the total percentage is 208.45%. To get the weighted average, divide the total percentage of the protein sources by their total parts. Then repeat the formula to the energy sources. After that, apply the technique on what you did on the first example for doing the Pearson's square technique. So, the another method is the multiple or trial and error method. It is a method where the total protein content of the diet is calculated by just summing all the protein contributions of the listed ingredients. The calculated total protein contributions of the ingredients are often not equal to the protein requirement. And lastly, to formulate a diet to contain 25% protein. For feed evaluation, there are 4 major ways of evaluating feedstuffs and or feed formulation. First is the physical, biological, chemical, and lastly, the microbiological. For physical evaluation, two methods is determining the physical characteristics of feedstuff or a feed formulation. A macroscopic or gross observation, this refers to the evaluation and observation of the feedstuff or feeds, which uses the following senses: sense of smell, to detect rancidity and foul odor; sense of taste, to detect off flavor; sense of sight, to identify and eliminate extraneous and undesirable materials; to detect presence of molds and insects, and to observe the compactness of the feed; and lastly, the sense of touch, to feel and the hardness, softness, coarseness, and fineness of the feedstuffs of feed formulation. Microscopic examination is also another method by physical evaluation. This refers to the examination of feedstuff or feeds on their starch, bacterial, or mold and moisture content. For biological evaluation is a way of evaluating the effect of the food or feed on the animal itself. Two parameters used to evaluate the effect of food feed on the animal. First is the direct parameters, which is growth, tissue and skeletal changes, survival, and the direct parameters is for the feed conversion ratio or feed efficiency is for the food consumption, the protein efficiency ratio for protein consumption, and the productive protein value or apparent net protein utilization is for the protein utilization. So, these are the measures used in evaluating the food or feed under biological method. For growth, we can use any of the following: either daily weight gain, the specific growth rate, or the percentage weight gain. For food consumption, we can use any of the following. First is the food conversion ratio, which is defined as the weight of feed ingested per gram gain in weight of fish, or by food efficiency, which is defined as the gain weight of fish per gram of feed ingested. For protein consumption, you can use the protein efficiency ratio, which is defined as the gain in weight of fish per gram protein consumed. For protein utilization, you can use any of the following. First is the apparent net protein utilization, which is defined as the percentage of ingested protein, which is deposited as tissue protein, where PE is the weight of fish body protein and the end of the feeding. PS is the body protein weight before the start of feeding, and PI is the weight of protein consumed over the feeding period. For protein productive value, you can also the protein productive value or the PPV, which is defined as the percentage amount of added carcass protein after a certain period of feeding. This is synonymous with ANPU, or the apparent net protein utilization. So to check the amount of feed given, the PI, or the weight of protein consumed over the feeding period, is divided by the analyzed crude protein, is equivalent to the amount of feed given. So conversion of the above data in as fed basis into dry matter basis, you can use this formula. Also, for conversion of dry matter to fed as fed basis, so chemical evaluation, this is a method of evaluating feed which determines the amount of the 6 feed fractions or components such as moisture, crude, crude protein, crude lipid or fat, nitrogen, free extract, crude fiber, and ash contents through a system known as the proximate analysis. This method also determines the other nutrients that the feedstock or diet itself contains. So methods of determining the 6 feed fractions or components: for moisture content, or by oven drying the feedstock or diet at 105 degrees Celsius until constant weight is obtained. So for its formula, to get the percentage of MC, loss of weight during drying over the weight of example before drying times 100, or for the percentage of DM with weight sample after drying over the weight of sample before drying times 100, and then the percentage of MC equals to 100 minus DM. For the crude protein content, can be determined either by the Markov-Jadal or Jadal method, which estimates the total nitrogen content, which is in turn used to determine the quantity of protein by multiplying the nitrogen content obtained with 6.25. So this is example of calculation of the Jadal method. Another is the chemical score, a method used to determine quality of protein. This is done by comparing the EAAS in fish or feed protein with that of the whole egg protein. And lastly, the essential amino acid index, also for determining the quality of protein. If the EAA required by fish is not known, then compare the EAA of the diet to the species muscle to be fed. For crude lipid content, can be determined either by Falk method. Lipid is extracted by blending procedure using 2:1 ratio of chloroform and methanol respectively. For blind dryer, lipid extraction using first blending 1:2 is to 0.8 chloroform, methanol, and water. For second blending, 2:2 is to 0.8 chloroform, methanol, and water. And for the third blending, 2:2 is to 1.8 chloroform, methanol, and water. Ether extract, a traditional method of extracting lipid with ethyl ether in a Soxhlet apparatus. So for crude fiber content, can be determined initially by washing the organic residue that remains the sample material of sulfuric acid solution or the sodium hydroxide solution and ethanol in this sequence. Finally, by drying the washed fatted sample in an oven at 105 degrees Celsius until constant weight. For nitrogen, free extract determined by formula below, as you can see. And for ash, is analyzed by incinerating the fiber content in furnace at 550 degrees Celsius minus the 600 degrees Celsius until carbonaceous matter is oxidized. So that will be all. Thank you.